Okay, so now we will see how we can evaluate this double integral. It's a very basic question, very simple to solve, but there are a lot of important things that you'll understand about double integration while we solve this question. Now, the first point that I want you to note, when you see a double integration, there are two variables. One is x, another is y, right? So now understand that when you're writing, now if you see the limits of this inner integral, inside integral, the limits are in terms of x. And what that means is these must be limits of y. And that's a very important point that you have to note, that when the limits are written in terms of x, do you see x? Okay, they're written in terms of x. They're always limits of the other variable. So it's like y right now. So these are the limits of y. That's first point. And if these are the limits of y, this has to be limits of x. Okay, that's quite obvious. Now the first point that I want you to note in a double integration, that remember this, always evaluate the inside integral first, or the inner integral first. That's always the rule. So you'll evaluate inside integral, that is the integration of y. That's one. And the second is, while integrating with respect to y, treat the other variable x as a constant. This is how we do it. So you will treat x as a constant while you integrate with respect to y. Now, if you clearly see that if you're integrating with respect to y, this x will be treated as a constant. And if it is a constant, it can straight away come outside the integral. Okay. Now, after discussing all these points, let us start solving the question. The first very important thing you should always do is let your integration be equal to I. So I'm just calling it this whole thing as I. This is x, the limits are from 0 to 1. Then I take that x out, this term here. And then now this is integration of y equal to x squared to x. These are the limits of y. And maybe I can just multiply this y term inside to this bracket. Okay, it will become xy. And then the next term will be y square dy. Okay, so I have isolated this integral of y inside, and then this is dx, right? Now let us start integrating the inner integral first, right? So integration I x equal to 0 to 1 x stays as it is, and here we're going to integrate this. Now please understand, this is the integration of y, okay? And as per the rule here, that we're going to integrate with respect to y and treat x as constant. So look at this as a constant, okay? This x over here is just a constant. And integration of y is going to be y square by 2, okay? So this will become, x remains as it is. This will become y square by 2. Then integration of y square is going to be y cube by 3. And limits of y are going to go from x squared to x dx. Okay. Now, after we evaluate the integration, now we'll substitute. First, you will substitute upper limit, and then you will substitute lower limit. Okay. So first, replace all y with respect with x, that's upper limit, and then replace all y's with lower limit, that is x squared. Okay. See how it goes. So now the integration I is going to be integration x is equal to 0 to 1 x, that will remain as it is. Now I'm substituting the upper limit, and that is only for y. Note that this is the limits of y only. So we'll replace for y over here, and we'll replace for y over here. Let's see what happens. So this will become y equal to x. If I do y equal to x, it will be x squared, and then there is a x, so this will become x cubed by 2, right? And then the next term, if I put y equal to x, it will become x cubed by 3. Sorry, that's x cubed by 3. Okay, that is basically u. Okay, the upper limit I substituted in this whole thing minus the lower limit of the integral. So now I'll have to put x squared as y, it will become x raised to 4, and then there is one more x, so there is x raised to 5 by 2. Okay, and then when I put x square over here, that will become x raised to 6 by 3. This is going to be x raised to 6 by 3, right? X square x raised to 6 by 3. That's the lower limit. I hope it's all correct. Okay. So once we get that, let us simplify this a little bit. X cube over here. So it's going to be I equal to x equal to 0 to 1. Then this is x. Okay. X cube. This is half plus 1 by 3, this term over here, I took x cube common, minus, this is x raised to 5 by 2, and then this is minus x raised to 6 by 3, and dx. So that minus sign comes inside. Okay, fair enough. So once you get that, let's just simplify these terms. It's going to be 5 by 6, right? 3 to the 6 and 3 plus 2 is going to be 5. Just cross multiply. So this is 5 by 6. And then I can always multiply this outside x term to this whole bracket. Okay. And let's write down I. The integral I is going to be integration x is equal to 0 to 1. And then this will become 5 by 6. X cube will become x raised to 4. So this x cube I'll multiply by x. So it becomes x raised to 4. Now tell me quickly how will that be? This will be minus x raised to 6 by 2 minus x raised to 7 by 3 and whole dx. Now this is a very simple integral. Of course, you know the formula, right? What is the formula? Integration of x raised to n is going to be x raised to n plus 1 upon n plus 1. Okay, so we'll use that formula and solve this over here. So I is going to be 5 by 6. Okay, this is x raised to 5. The integration of x raised to 4 is going to be x raised to 5 upon 5. Minus this integration is going to be x raised to 7 by 14. Minus this will be x raised to 8 by 8 3 24. And now the x will go from 0 to 1. So let us substitute upper limit and lower limit. I believe this 5 will cancel out. So when I put the upper limit of x is 1. So when we put 1, this will become, the first term will become 1 raised to 5 is 1. 1 by 6 minus 1 by 14 minus 1 by 24. And that's upper limit. For lower limit, you're going to get a value 0. So this is how it is done. And then you will get the final answer of I. Okay. And I hope I'm correct. I hope there is no mistake. But then you just have to do this number crunching. Find out 1 by 6 minus 1 by 14 minus 1 by 24. And you will get the final answer over here. Okay. But then I hope you followed the bigger picture, the more important things, which is how to deal with a double integration. That is what I tried to explain in this problem. Okay. And I hope you followed this.